Okay, great. Hello, everyone. Thank you for joining today's meetup. This is the online English meetup group. Today is December 16, and we have today's topic is circuit breakers in MuleSoft. So, a very popular topic, and a lot of attendees have requested this in the past. So we have Tiago today, who is gonna do our topic presentation. But before we I hand over to Tiago. We're just gonna go over quick instructions, and then Tiago will take over the presentation. Tiago, next slide, please. So today's agenda again, we are going to do a quick overview. We're going to talk about some of the out-of-the-box policies, the capabilities that we have on the platform, and then Tiago is going to take us through some of the API-led use cases. Then we are going to do a demo, and then end the session with Q&A. Next slide, please. So these are the organizers for the online meetup group. Royston is representing JPAC. Angel is handling EMEA, and Manik and myself are representing AMER. I'm working as a customer success technical architect, part of the customer success team in MuleSoft for the past 3 years, and happy to be your host today, and looking forward to organize more meetups in the future. Can you go to the next slide? Just some guidelines for today. When Tiago is presenting, feel free to use the chat feature in the platform, and someone will try to answer. And or if something is not answered, we'll take those questions at the end. Uh, the recording will be shared on our meetups page, of course, and also on our YouTube channel, the VirtualMuleys. So please make sure that you check it out if you miss part of the session. And at the end of the session, we are going to send you a survey. Please provide your feedback if you like the session, if it was helpful, and also let us know if there is any topics that you would like to learn more about. Next slide, please, Tiago. Okay, so talking about the man of the hour, right? This person needs no introduction. I think if you're part of the community, you probably are already familiar with this name. Tiago has been, being a MuleSoft champion for years, and I'm glad that he has joined our team, and looking forward to a lot of sessions from him. So, Tiago, please introduce yourself, your experience, and take it over.
Absolutely. Thank you so much, Sandeep. Good morning, good afternoon, everybody. I hope everybody is doing well, especially during these crazy days. My name is Tiago Santos. I'm a senior technical architect at MuleSoft. I work with Sandeep as part of the customer success team. We try our best to support our customers during their implementations, questions, and everything related to the platform. Sometimes not too related, but we try our best just to set up everybody for success, right? That's our goal here. Today, I'm gonna be talking and sharing my knowledge about like circuit breakers, like how it works and the approach that I have seen with customers, the good, the ugly, about this concept, and of course, just to align everybody on the topic, right? I know that it's something that's, especially if you're a product manager or a project manager, is something that you hear a lot, but by the end of the day, like few people just understands exactly the meaning behind this functionality, right? Okay, to start, what's the circuit breaker, right? It's referred as a stability pattern, right? Made to avoid waste of resources. Okay, how this works. For example, if you do have like a backend system which is inoperational, which is down, right? You don't want your API to be calling these systems without a reason, because by the end of the day, like you're not expecting any results out of that, right? And of course, it's going to be wasting resources. In some cases, like for example, if you're using like a specific backend system, if you try to, for example, you have an exception for unauthorized access, if you try to ping that backend system for multiple times, you might lock your account, which is not useful. It's not ideal, right? Especially over the weekends. Like I have seen a lot of these issues happening before. And one of the solutions that we offer is the implementation of a circuit breaker, right? Just to control issues when they happen, right? It works exactly as your home circuit breaker, breaker, right? It's there just to protect all the infrastructure about unintentional calls. Okay, as I mentioned here, the idea is just to create a protected function around your system, just to monitor it for failures, right? That means you don't want people calling your system when it's down. This pattern it's covered by 3 states, right? It's commonly like the Microsoft pattern cover 3 states, which is the closed, which is the operational state, which is the first one. It's when the system is operational. You're gonna have your flow calling the destination system or API without any issues, and it's called the closed state. That's where it creates a lot of confusion. The closed, it's exactly as your home circuit breaker. When it's closed, that means it's operational, it's working, right? In our Mule developer language, I call it as a started state. When your flow it's started, right? That means it's operational. When there is an error on on that system, you can control that. You can define how many errors you'd like to receive before tripping the circuit breaker. Then that condition is going to be implemented here. For example, if my policy, my circuit breaker only allows one error before tripping it, then I'm going to be mentioning as part of my properties. And then whenever I receive the first error based on that specific type, that means I can control the number of errors that I'm expecting before tripping it, and the type of errors that I would like to support as part of my circuit breaker logic, right? That means if I have more errors than the allowed, then the circuit breaker is gonna trip, right? That's considered the open state, where all the messages are not being fetched anymore and not gonna be processed anymore, right? That means no more connection to the destination. Us on the open state, the next step is to verify if the system is back online again, right? That's why we do have a circuit breaker. It's some sort of auto healing functionality. That means the circuit breaker is gonna try to send a test message to the destination system. Okay, it's gonna be turned into the half open state, and it's gonna try to send a single test message to the destination system just to double check if it's back online again, right? Or maybe that intermittence it's gone. And then once it succeeds, then we are gonna have like back to the closed state. It's gonna be back operational again, right? Otherwise, it's gonna go back to the open state. It's gonna stop working again, and then wait for the threshold, the trip timeout, maybe another 60 seconds, and try another test message and check it's back online again, right? Okay, that's great because it reduces a lot of operational overhead. You're not gonna require a lot of people on top of logs all the time. You know, most of the solutions, especially if you're working with a mainframe, that works like that like solves most of the problems with such solutions is stable systems, systems that have like a limited capacity, right? So that's ideal for this sort of systems. Okay, let me just jump into the next slide. Give me just a second. Okay, we do have multiple use cases of circuit breakers, right? These are the most common use case. We do have the asynchronous type of circuit breaker, which is commonly used with pub subs, right? It's on the listener part. That means the only goal of this sort of circuit breaker is to stop listening for new messages in case of issues with the backend system. For example, if the system is offline, then the idea, the feature, the functionality behind this circuit breaker is to stop listening for new messages. That means you're not gonna end up with a lot of poison messages on your message queue, and of course. You're not going to be pinging your backend system unnecessarily. That's why we do have the circuit breaker implemented on the listener stage. Okay. As everything in life, there's the good and the bad about it. The good, it's like it's applied on the logic on the source. We do offer as out of the box configuration as part of any point MQ connector. It can be easily configured without any custom code applied. And the best part of this approach is you're not gonna face any sort of message loss, right? Because we are following the reliable pattern in this use case, okay? The bad, it's not supported out of the box with most of the message brokers available in the market. For example, we don't have like a feature as part of the SQS connector or Solus or ActiveMQ or anything like that. It needs to be, in this case, configured like manually, like in a custom way, okay? We're gonna talk more about the custom approach, things to consider. Of course, we can also clarify some questions at the end, but the whole goal of this presentation is just to cover the use cases, the high level approach. And of course, you're going to have a demo at the end just to highlight how the whole out of the box functionality works. Okay, just very important point. Even if you're using Endpoint MQ, the rule of thumb will be always, the poisoning states will be always forced on the TTL level in the message queue. That means like it doesn't matter like if you have like a 1 hour threshold, the TTL for the message will persist always. It's gonna be the most like the most important information that you're gonna have to check if that message is gonna be available on your queue or not poisoned, right? That means if your backend system is down for like a week and your TTL it's like 2 days, that message is gonna be poisoned either way, right? Because the priority will be always on the broker, right? The circuit breaker will not overlap the broker functionalities, right? Very important point to highlight. Let me jump to the next slide. Okay, talking about the custom circuit breakers, like for example, if you're using SQS, things that I hear a lot from lots of customers that they implemented a custom logic and works great with one worker, and then they have like a requirement for high availability. They increase the number of workers, and then the solution only works on the first worker for a single reason. If you follow the custom path, right, it's gonna require you to set up a scheduler to check the state, and of course to restore the state of the circuit breaker. That means you need like a scheduler, and that scheduler is gonna be set up on top of like a specific threshold for the trip eviction, right? That's why that scheduler, as an additional part of our design, it will only work on the first worker, right? The scheduler is not designed by default to work on any secondary or the third worker. It's just made to work on the primary node only, right? That means you're gonna require some sort of a different logic in order to apply such circuit breaker. My apologies on that. That means like most of times, like we see people fetching the messages from SQS and persisting it in a VMQ. And then you can have listeners like across all workers. That means your business logic is gonna be on top of the VMQ listener if you want to apply in a high available way, right? That's why you're gonna require the implementation of a VMQ aside of your SQS queue. Every single broker follows a different logic, right? That's the logic for SQS. I'm not saying that you must use VMQs, but that's one of the easiest way to work around these like scheduler like limitation. Okay, that's exactly how it works. I have just put like a simple flow here to show like we're gonna be receiving the message from the SQS through the listener, publishing, persisting this message on a VMQ, and then have these VM listeners consuming and implementing the business logic. Just to highlight, the scheduler, the listener must only run on the primary worker. okay? There is an advanced option to run only on the primary node if you go on Endpoint Studio, okay? That means these two flows are just gonna be available on the primary worker. The other workers will be only there to consume the message from the VMQ. Okay, I hope this approach is clear. It's just a high-level approach. I don't want to drive into a lot of details in terms of custom circuit breakers because every single company has a different requirement, right? Some companies requires integration with their IT ops, ITSM system, just to make sure that what's happening, what's working, what's not working, what's being tested through the half open state, and etc. Okay. Following the synchronous use case, okay, let's talk about the ways of implementing a circuit breaker in a synchronous integration, following the API-led approach. Okay, that can be implemented in two ways. You can use a custom policy, right? We do offer like a custom policy template on our Catalyst Git repository. Okay, just to highlight one very important thing. That policy is not production ready, right? That means it's gonna require you to do some amendments based on your own needs. It's just a template, it's just like a foundation to your custom policy, like custom circuit breaker policy, right? It's just there to help you start from like a foundation with the common properties and the common logic, but it requires like some customization based on your needs, and of course it requires some tests. That's the remaining part. Of course, tests are going to be based on your implementation. Please, I'm going to be sharing the link after this meeting. Please feel free to go fork or clone the repository, implement your own changes. You can also implement that policy in a free trial account. You don't have to start implementing on your company org by any means. Like you can try yourself before you bring up the idea internally. Okay. The good about that, it's like you're gonna have like quicker response. For example, if the backend system is down, that means like you don't have to wait for the timeout to go. You know, the following requests do not need to wait for the timeout in order to receive like a error message, right? It's gonna be like faster for everybody, and of course, like it's gonna reduce the stress on the backend system and then those in downstream APIs, right? It's easier as well to handle events, right? Like for example, you're gonna have like free access to customize what's gonna happen when the circuit breaker close. Like maybe you might call your ITSM system for some information, log specifics on that. Like for example, when it's open, and when it's half open, you have like full access and full like freedom just to add everything that you're looking for there. Okay, the bad about it, it's just not bad, but it requires a little bit of custom code, especially for users that are not too familiar with development. That's not too easy to implement. It's gonna require some research. And of course, you're gonna like see some sort of intermittent experience. What do I mean with that? It's like why is in the half open stage the policy will try to make connection with the backend system. For some users, it's a not common behavior, right? That's why it requires some explanation on your documentation, just to make sure that everybody understands like what's the current state of the API, right? In some cases, I have received some feedback. People think that that's a great solution, but it provides an intermittent experience, right? And of course, because we're not persisting the message anywhere, we're gonna also have some message loss in case of downtime. Okay, it's just going back to our lightweight secret breaker, which is available on GitHub. It can be easily downloaded, right? If you go to this URL, you're gonna be able to clone the repo for free. Okay, but there is one like major requirement that you must have, which is a Nexus Enterprise credential. Okay, that can be requested with our support team if you are an enterprise customer. Why this is required? Because some of the dependencies of the custom policy, it's hosted on our Nexus repo, right? That means you need these credentials on your Maven settings file. Okay, if you don't have it, then you're not going to be able to package the solution. Okay, pretty straight, very important point, and pretty straight to set up. I'm going to be sharing this presentation. I put also like a screenshot with how my settings file looks like. Okay, just like as a new user, anyone can go and set up in a similar way just in order to package the solution. Again, this work on try accounts as well. You can set up a free account and try by yourself. You don't have to try on your organization account. Okay, next step is to set up the right group ID. Okay, what's the meaning of group ID? It's the organization ID on your endpoint platform. In this case here, I'm using my try account. I just went to organizational info on access management. Then you just need to copy the organization ID and place on your POM file. Okay, that's the next step. Okay, and then last but not least, you must add some extra repositories here. Okay, you must add the Nexus repo as part of your POM file. Otherwise, Maven will not be able to download some of the dependencies. That's required. Okay, of course, every single POM configuration, parent POM, bills of material are different. I'm just trying to set up in a way that's it's workable for every single one of us here. Okay, just a generic way of making the solution to work. Okay, you can move this to a parent POM in the future, or set up any different configuration. Okay, and to finalize, you can just package the solution. Okay, I put in two separate steps here just to simplify. You can package the solution to create the jar file and then deploy to your exchange. Okay, you just need to type mvn clean package, wait to build the solution. If you get a success, that means you're good to go, you're ready to deploy. Then you just go and deploy the solution. You can do this in one step. If you want to type mvn clean package deploy, it's going to package and deploy as part of a single command, right? And then after you have this installed, the only thing you need to do is to implement this policy on your API manager. You're gonna see this policy as part of the custom category. Then you can just set up the failure threshold. What means like how many errors should I expect before tripping the circuit breaker. In this case, just put one, okay, which is common, right? If I get it like some sort of timeout, I just want to trip this circuit breaker straight away. I don't want to wait for the second error because I know that my integration is busy. It has a high volume. Then that's my expectation to trip on the first error, matching that specific error code, right? That means, and then I would like my solution, my circuit breaker to be back on the half open state after 60 seconds, right? That's how it works. Then after 60 seconds, any request that happens between these 60 seconds are gonna be rejected. You're gonna see like a circuit breaker error message there saying, hey, I'm sorry, this solution is down. And then you can add some extra properties saying, hey, it's gonna be back by this time, right? Then you can have like an expectation of when the solution is going to be available back again, maybe available back again, right? This custom policy provided by MuleSoft, it gives us two options. You can filter by status codes, right? Error status code. You can put like 500, for example, 401, for if you have like a system that it's giving you trouble with credentials, anything related, right? You can also define the error types as well. For example, if you have like a timeout or like anything like timeout or not found or anything like that, you can define here or on the error type. You can define the arrays on both sides and apply. Okay, again, you need to implement your logic based on your own needs. That's just a template and not intended to production on its current state. Okay, and that's it. It's demo time. Please feel free to drop your questions at the chat window if you have anyone. I'll be more than happy to answer. Okay, starting here to the solution. I'm gonna be demo today. Asynchronous integration, okay, using a PubSub, using our endpoint MQ. We do have one process API which just listens to new messages from endpoint MQ and creates an account record using the CRM Microsoft SQL Express 2019. Okay, that's exactly how the solution works. I do have both solutions here on my Endpoint Studio. The first one, which is the system API. Let me just open the logic here to show everyone. Okay, it has two endpoints. One to query the records from accounts, and another one that inserts into the accounts database. Okay, again, I'm using like a SQL Server Express hosted on GCP. This is operational right now. Like as you can see, we don't have any records. I'm gonna be just inserting a new record through my MQ. Okay, we are gonna see. Let me just open the logs for my process API. I'm gonna create the first company called MuleSoft. I'm gonna send to my queue. And then it's created here. If I select, I can see MuleSoft here. It has been created without any issues. That means my API is up and running. But what's gonna happen? How can I treat my circuit breaker in this case, right? As you can see, our system API, our process API, my apologies, it has a circuit breaker on the listener. Okay, I'm using endpoint MQ. That means all the circuit breaker has been set up on the global elements file. Okay, I do have like a global circuit breaker. I have my endpoint configuration here. Let's open the circuit breaker. I have set up this circuit breaker to only trip when my system API times out. Okay, that means that's my system API. That's the timeout type that I'm expecting. Okay, that means if my system API times out, okay, if I after one error, then I would like just to hold requests on these on these like I would like to hold any new messages from my broker. Okay, and then what's gonna happen here? This circuit breaker is gonna wait for 1 minute. Okay, 60,000 milliseconds in order to fetch another test message to test one single message. If that succeeds, then my circuit breaker will be closed again and all the other messages will be flowing accordingly, right? I think this is pretty straightforward. That's how I set up my circuit breaker. I can have multiple circuit breaker configurations as part of my global elements. And then when I go here to my API, here we go. I just have a listener here, and then if I go to the advanced tab on the listener, you can see that I'm selecting the circuit breaker that I set up on the global configuration, right? And that's exactly what's going to happen. And then what I'm doing here is just creating like a single record using my system API for SQL Server. Okay, okay. Just to proceed, let's do one thing here. This solution is on Cloud Hub right now. I'm gonna be pausing my SQL instance on GCP right now. I just go to overview and stop my solution. Okay, that means my backend system is down. Nobody's gonna be able to. Here we go. It's down. Then if I try to hit my backend system from Here we go. It's fail. Can you see? Like there is no way to connect to the system. That means if we go and publish another message into the queue. Okay, JSON, fine, okay. Then we're gonna see the error with the timeout. It's trying to execute for the first time. Okay, I got my exception here. Okay, if we go back to the queue, oops, sorry about that. We still have one queue hanging on the queue, right? One message hanging on the queue. Like as we set the threshold every 60 seconds, that means the solution, the circuit breaker will try to send another message, another test message after 1 minute. Okay, if that failed, then it's gonna wait for another minute. If that fails, so on and so forth, right, for another minute. If I, let's just add another message here. I'll just copy from Tableau. So that's JSON, okay. Then if we go back here, center. Okay, now I think it's there. Here we go. And now I have 2 messages here on my queue. That means no requests are being made during these 60 seconds. If I have like 1,000 messages here, nothing's gonna happen, right? The queue will be paused, the listener will pause automatically, and nothing will be processed during these minutes, right? That means I know that like my backend system takes approximately 1 minute to restart. Okay, let's just go and restart the SQL server. Okay, again, let me just jump into here. I'm unable to reach the server. Okay, let me just start this again. It's a little bit slow, but yeah, we do have 2 messages hanging here. I just want to hear, is there any question? I'm not seeing any questions on the chat yet.
Yeah.
Please feel free to drop your questions.
Yeah, Thiago, we have a few questions. Uh, is this configuration can we do this outside any point MQ? Can we use any other queuing mechanism?
I don't think I don't think IBM MQ will have like out of the box functionality for secret breakers, but you can set up your own logic using schedulers. There is also some libraries, some third-party libraries, which I really don't recommend, but you can use as a reference. But yeah, you can build your own custom logic in this case.
Got it. And will you be supplying this code that you're demoing in a GitHub repo later?
Yes, I will be sharing a Git repo. Yeah, after this call, absolutely.
Yeah.
Okay, let me see if the database is back online again. Okay, that means it's an auto healing solution, as you can see. As a Mule resource, I'm not expected to do anything. The SQL is still restarting. The instance is still going up. I think it's already up now. Let's see here. Okay. It takes a couple of minutes to start.
Yeah. Thiago, are you able to show the content of the test message that you sent?
Yeah, absolutely. It's right here. If we go here, message browser, that's a message sitting there. Of course, he's still trying to send the message. The database is down. Salesforce. Oh yeah, we have to upload Salesforce. Okay, these are the messages sitting on the on the queue. Let me go back here. I want to release the messages because I'm locking by doing this. Let me see if my database is back online again. My apologies about the delay. It's quite slow. Sorry, guys, it's still starting. Let me refresh here to see.
Hey, Diego, do you have a minute to take another question?
Yeah, absolutely. Yeah, go ahead.
Yeah, so is this pattern only applicable for messaging or queuing? Can this also be applied for HTTP listeners?
Yes, the other two approaches that I show on the second slide for synchronous integration, it's for example, if you set up like a policy that's gonna apply for the listener connector, right? That's gonna apply automatically to the listener. Okay, just to be clear. Give me just a second. Let me see if this back online again. Okay, we're back online. Let's look at into our oh boy. Okay, let's wait for the next execution. Let me go back here to the queue. Okay, we don't have any messages here. That means, yeah, all the records has been processed. Can you see here? ID 2, 3, and 4. Okay, that means we resume the database and then the listener start back again, right? Now the circuit's closed. That means it's back online again without any intervention. I was not required to stop the application, restart the application, stop doing anything like that. It's just auto heal based on the state of my backend system. Okay. If we go back here, let's just try to select from accounts. Now you're gonna see like the next the records. Well, MuleSoft, I hit like send twice on the Tableau, but yeah, we do have all the 4 records available right now. Okay. I can see some other questions here on the QA. Let me check. Which one have you stopped, Sandeep? Help me out here.
Yeah, so we can start with Arvind's question, Tiago, the deadlock occurrence. Yeah.
Okay. Okay. Could you please be more specific when you mean like deadlock on where on the queue itself? Like, could you please be a little bit more specific?
Maybe I can read out the next question to you, Tiago.
Okay.
Yeah.
Sure. Go ahead.
Yeah, to store the state of the circuit breaker, what kind of persistent storage is recommended? Is object store a good choice, or we should use database?
Really good question. I would always suggest like object store, persistent object store, right? That would be the rule of thumb for the states of the circuit breaker. Okay, the circuit breaker, it's there to help us with stability of our application, right? That means it should be highly available. That means you must use like object store persistent in this case.
Great.
Okay.
One more question from Bipin. What happens to the in-flight messages while the polling was stopped?
And they are going to be returned to the queue, right? That means they're not going to be acknowledged. That means, for example, if we have a message, the listener is going to fetch that message. And of course, the broker is waiting for the acknowledgement or not acknowledgement of that message. If that message fail, it's going to be returned back to the queue, right? And the listener will stop working. It will not fetch more messages during the threshold, during the waiting period, right? That means in our case, we do have like a 60 seconds wait. If we have any timeout issue, then the listener will stop listening for the messages, wait for 60 seconds, and try us again with a single message. It's going to fetch one message. That means we're going to have one consumer. It's going to try to complete and get that message acknowledged. If that succeeds, then it's going to open the gate again for all the other messages. I think that I hope that answered your question.
Thanks, Thiago. So next question is, will the object store usage add additional cost to the organization?
Yes, you're still using your object store capacity. Okay, that's a really good question. By the way, one thing that you can do if you think that's like a, a problem for you, you can use like a custom Redis instance, okay, hosted by your company, and use that as object store. You don't need to perform any change on your connectors, on your object store connector. That connector can be easily extended to use Redis, right? That means that's gonna increase your capacity, okay? In case if you require more than 10 transactions per second per application, okay, just to highlight. And also there is a custom property that you can use if you want to make that policy object store available across all applications, right? There is one property I think I do have available here. It's not required, just in case if you have a specific configuration. Uh, Let me just go back here. I think I have these available as part of these properties. Yes, you can use the global sharing, okay? What's gonna happen is that if you have like, if you're using object store on your policy, those keys are gonna be available across all the applications that are implementing that policy, right? That means everybody's gonna be able to see the keys from other like applications as part of that global sharing. Okay, I think that's the easiest way to explain. You can find more information on the Mule website. Okay, we share like all the details, technical details behind the global sharing functionalities. Okay. Next question. I hope, please, guys, if I'm not replying the way that you're expecting, if any additional question, please let me know.
No, I think you're addressing all the questions, Thiago. I'm getting response from the attendees that it's been answered. So yeah, we're good. Uh,
Okay, good.
so Thiago, just to extend on that question, right? So the free tier should be good enough for CloudHub, or there would be.
Yeah, you can try the solution using the free tier. This is a free tier account. Okay, just to is a Thiago Santos PLC. You can use our free tier account for testing your own circuit breaker, right? You don't have to go to your organization, break things around, use your vCores for these POCs. You can do it on the free the try account. As you can see here, this is a developer try account. Okay, you can do
Yeah,
it
for the
yourself
object
without any
store.
problem.
Yeah, the object
Yes,
store.
you can. Yeah, you can do it. You can do it. Yeah, you can do it on the try account for sure.
And for on-prem, it is always on the customer side, right? For objects.
Exactly, it's on the customer side. On-prem, again, if you have like a transition, it's gonna be on memory, on the application memory. If you have like a persistent, it's going to be on disk, right? It's gonna be a little bit slower, but it's great because it's gonna be persistent. And you can also use like a external Redis instance. If you do have like a Docker image with Redis, you can just use that as your object store, right? In case if you have like a lot of requests, you request like a lot of transactions per second. I highly recommend you use a custom, like a separate Redis instance in this case.
Thank you, Diego. So we have one more question from Gunandi. Uh, what is the other alternative solution to circuit breaker? Are you aware of any?
Yes, there are a lot of alternatives. We're just covering like we're covering three. We covered the endpoint MQ out of the box one, okay, which is the easiest to use. Okay, if you do have endpoint MQ, go for it. It's very easy to set up. Few minutes and we're ready to go. You have an in-app sort of circuit breakers. That means there are some components available online. I think Patrick, one of our MuleSoft investors, have a nice article explaining how this works, right? You can also a package from GitHub and deploy in your Exchange and use those. I cannot endorse these components because they're not validated by MuleSoft, but you can use them if you want. Okay, it's on your own risk, of course. We also provide like a foundation, a nice foundation for a policy, a custom policy circuit breaker, okay, that can be easily modified and follow all your needs. And also, last but not least, you can have your global load balancer performing working as a circuit breaker as well. I have seen cases that people use their like F5 as a circuit breaker. It can be done as well, right? These are one of the approaches that can be done. It's of course it depends by from company to company, right? Some companies prefer to do it this way, some companies another way. Just please uh, pay attention that these extra functionalities will have performance impact on your application. Not much, but yes, you're going to be consuming resources in order to execute your logic, right? If you don't think that's the best way to do it, you can use your load balancer to implement circuit breakers as well.
Great. So we have one more question from Rajesh. In your custom circuit breaker solution, which uses Amazon SQS and the VMQ, is there any chance of message loss or message duplication for more than one worker?
Uh, no, if you use a persistent VMQ, right? If you're using a persistent VMQ, that message is going to be sitting there, right? Is what you're doing by the end of the day, is sending a message from your customer SQS to your own MuleSoft SQS, which is a VMQ, right? It's just doing this transition. Of course, you have to use transactions as well on the VM. Just make sure that you're not losing any message. XA transactions are very important in this case if you are planning to have like a zero loss here. Okay. I hope this answered the questions.
Yeah, Rajesh, if
Okay.
this answers your question, just give like a thumbs up or put it in the chat. Next question is from Bitan. Uh, the custom implementation would mean you need to stop the flow uh, polling, right? Is it a good practice to stop the flows programmatically within the application?
Yeah, it's a common practice, right? It's done by a lot of I have seen so many applications, right? It's usually used on custom implementations. In this case, in my opinion, I think it's the only way to go, right? One of the only ways to go is to stop the flow, okay, in order to stop a listener. Yeah, that's the most common approach.
Great. Going back to a question from from Rajesh regarding the custom SQL solution, he wants to know how can we address duplication concerns.
I don't think you're gonna have duplication concern, like any duplication problem with the solution, because as the message fail, it's gonna be returned back to the broker, right? I like, for example, if you're following the custom approach, let's talk about this use case here. Okay, each message is gonna be consumed by a different worker. Okay, the message will not be the same message will not be sent to to different workers at the same time. That's how VMQ works. Okay, I'm not sure if I'm answering your questions. Please let me know if you have any additional questions or if I'm talking about something else that is not intended.
Yep. I think it answers the question. Thanks, Diego.
You're welcome.
We have one more question. Will the MuleSoft provided circuit breaker work with only Enterprise Nexus account? Can it work with any? Uh, if the user is not an enterprise customer, can that solution work?
I don't think so. You can try by reaching our support team, right? I'm not sure if they provide any access to POC users. I'm not sure about this, but I don't think so. Okay, just being realistic, I don't think that's provided without the enterprise account.
Great. I think we have one more question that needed some more context about the deadlock question. Let me get back to that. I think, let me see. Yeah, so what are the possibilities of deadlock occurrence? And the context was on the queue, as there is a wait period involved in the logic. I don't know if that question makes sense now.
Yeah, it makes sense. That's good to answer. Yeah, I got your point right now. The point is, your queue has a TTL, okay, a field called TTL, okay. That means the message is going to be available for 7 days. That means if your backend system is down for 8 days, this message is going to be poisoned, right? It's going to be poisoned automatically because you're exceeding your TTL, okay. That's the primary consideration in terms of availability. Okay, it's your TTL. If you require more, you must bump this value. Okay. Yeah, you can alter the TTL. Just answer Arvin. Yeah, you can alter the TTL if you want. And in point MQ, you can change also the delivery attempts before reroute. Okay, what that means. If that message is necked and not acknowledged for 10 times, then that message is going to be moved to the dead letter queue. Okay, that is a configuration. Let me go back here on any point MQ. Let me just click on the right place here, right? Can you see here? I have a secondary queue that acts as a dead letter queue, okay? If the TTL is reached or if the number of attempts exceeds, then the message is gonna be moved to the dead letter queue, okay? Of course, I can have like 3 layers, like I have seen like so many implementations with a normal queue, a retry queue, just show he tried for at least 2 times, and then the message is moved to the dead letter queue. You can have as many queues as you want as part of your hierarchy. Okay, I hope this answers the question as well.
Yep, it does. We have one more question from Virendra. Do we have documentation in MuleSoft that explains how to extend Redis as object store? Ye- Yep. Diego, you're on mute.
Right, yeah, I think this answers the question. It shows step by step how to configure, right? You need to set your object store configuration to no cluster, and then add your Redis host here, okay? And then, yeah, you're gonna use the normal object store connector. The only difference is it's gonna forward all the message to your Redis instance instead, okay? That's exactly how it works, but it's pretty transparent. You can run this locally if you want. You can, if you have Docker on your machine, you can try this locally by executing these commands, right? And see how everything works. And there are also one software. It's not free. I think it's Redis Explorer, something like that, where you can see how many keys and partitions you have on your instance available. Okay, pretty cool.
We have a question from Yannick, Thiago. Let me just
Mm-hmm.
read it. It's a big question. Maybe you can also take a look at it. Uh,
Sure.
so, yeah, so he has a question around Azure Service Bus, which does not support out of the box circuit breaker. They created a custom scheduler that runs on both the workers, as the service bus runs on all workers. Uh, Hold on, I need to go over it.
Yeah, the scheduler is not running on the second worker. Okay,
Yeah.
that's exactly what we cover over these slides. Uh, it's intentional by design. The scheduler on a Mule solution, if you have 8 workers, it will only run on the primary worker. Okay, that's by design. You cannot have the scheduler running on these workers. Please have a look on your worker logs, and you're gonna see that your scheduler is not working on the worker 2 or 3 and so up to 8, right? Like it's not gonna be working there. That's why it's important to think like in this line here, okay, to forward this message to a component that has support across multiple workers.
Yeah, so they're using some custom solution, Thiago, to distinguish between the workers using IP standard IP variable. Uh, the concern is that that solution might not work for on-prem or cloud, but just want to know if there is any solution to distinguish between workers or any approach in general.
You can get the host, right? If like there are many ways of doing this. You can check for the host. If contains Cloud Hub, it's a Cloud Hub solution. Like if it's on premises, maybe by the IP. Like there are so many ways to detect the environment. But I would say that this solution will differ a little bit according to the topology, right? I would not recommend to have like a universal solution that it's deployable straight away on the Cloud Hub and on premise. It can be done for sure, but it's gonna be a really like hard task to accomplish.
Great, thanks, Tiago. I think we are coming to an end of our meetup, Tiago. Again, I want to say thank you for taking the time and going over the circuit breakers and the different patterns on it. And for everyone who has attended today's meetup, please take a look at the recording if you have missed any part, or if you want to go back and review some of the points that Thiago talked about. This will be posted on our Virtual Muleys channel. And again, have a great day. Good night, everyone, and uh, have happy holidays. Thank you.
Happy
Thanks,
holidays,
everyone.
guys. We do for sure.